derivative should be the 2 comes out front. Then I have x, and then I subtract 1 from 2, so 2 minus 1. Well, this is just 2x to the first power, but we usually don't write the first power, so this is just 2x. So the derivative of x squared should just be 2x. Another example. Let's say we have f of x equals x to the 237th power. Well, again, we have a base x. We have our exponent is this number 237. That's our n. So by this power rule, it should just be the 237 out front. X raised to the 237 minus 1 is going to be 236. And that is it. We're done. Very nice, very short, very quick, very easy. Next one. Let's say we have f of x. This sure beats the limit, doesn't it, doing all that stuff? How about we have square root of x? All right, well, first thing we have to do is realize that square root of x is really x to the 1/2. So if I look at that, I have a base, x, and I have a power, which is my n, which is 1/2. So the derivative should be that 1/2 coming out front, then my x, raised to 1/2, take away 1. But 1/2 minus 1 is negative 1/2. And remember with negative exponents, we don't like to leave things with negative exponents usually, but you can. It's not wrong, but we like to rewrite it. So rewriting that as a positive exponent means it needs to be pushed to the bottom. So we'd have 1/2 times 1 over x to the positive 1/2. But that's the same as 1 over 2 times 1 over the square root of x, which is the same as 1 over 2 root x. And that's the way you should remember it. This one comes up a lot, so you should just probably put this into your memory bank. The derivative of the square root of x is 1 over 2 root x. Remember that one. Let's see, we could try something else. How about f of x equals, let's say, 1 over the 5th root of x. So let's try and find the derivative. Well, we first need to realize this is 1 over x to the 1/5. And then, before I use power rule, I need to bring that up and rewrite it as x to negative 1/5. That way I have a base, and then I have an exponent that is a number. So the derivative should be, that number should be dropped out front, negative 1/5, x to the negative 1/5 minus 1. So this is negative 1/5, and then when you subtract 1 from negative 1/5, you get negative 6/5. And then, again, dropping that down, negative 1/5 times 1 over x to the 6/5, which is negative 1 over 5 x to the 6/5. And that will work. Okay, let's take a look at another example here. I think I've shown enough here, maybe. Let's just try one more. How about f of x equals 1 over x? All right, same thing. Bring x up, rewrite x to negative 1. Now take derivative. Power comes out front, negative 1. Subtract 1 from the power. 1 minus 1 is negative 2. Drop that down. When I drop it down, I'll put the negative on top. It'll become x squared on the bottom. Okay, so now we're kind of seeing how this is going to work. I think what I will do is I will defer. I will not show you the proof of the power rule at this point in time, because I think you've got enough on your plate to work with. So if you're interested in that, please just contact me. I'd be happy to show it to you. All right, so how about one more rule that we can take a look at before we finish this up. Let's see, that's our second rule. And we had our third rule is the power rule, so fourth rule. Okay, fourth rule says that if you are trying to take the derivative of a constant, now we already know the derivative of a constant by itself is 0, but if it's a constant times a function, okay, this rule says that what you can do is you can pull the constant out front and then just take the derivative of the function. So you don't have to worry about the constant. The constant will just come out. Let me show you an example of this. Let's say we have some function, f of x equals 4x to the fifth. So what we want to do is we want to look at this 4 out here in front as being like our constant. And then we have a function, f of x, which is the x to the fifth. Now we know how to take derivative of x to the fifth because that's power rule. So what I'm going to do is I'm going to say that the derivative of this is equal to 4 times the derivative. Well, I'm going to use a different notation so you can see it. It's 4 times that x to the fifth, but it's derivative. So I'm just going to put a little prime mark on that parentheses. That just tells you, okay, I need to take derivative of that still. But the derivative of x to the fifth is 5x to the fourth. And now that 5 and 4 multiply together, it gives you 20x to the fourth. So the constant will come out. It'll just multiply whatever's out there. So nice result. I think that's good. Trying to wrap up a couple of things here. How about something like this? What if we have, as an example, what if we have, I'll use y instead. What if we have y is equal to x squared minus x plus 2 over x? Okay, what's the derivative of this? So what is that? What's y prime? Well, you might be sitting here going, wait a minute, we haven't done this before. We have a fraction here. Well, we do, but because we have a single term in the denominator, we can split this up into 3 fractions. We can go x squared over x minus x over x plus 2 over x. And then simplifying, we get x minus 1 plus 2 times x to the negative 1. So I simplified these two. Right, I simplified these two, and then that last one, I brought the x up top and made it a negative 1 as an exponent. All right, so now what we can do is we can take the derivative of each of these individually because they're separated by addition and subtraction. So my derivative will be the derivative of x, which we said earlier was 1, okay, plus the derivative of a constant. Derivative of constant is 0, plus, now here we have a constant in front of a function. Right? We have a constant here in front of a function, so I'm just going to write the constant. And now the derivative of x to the negative 1, the negative 1 comes down. I subtract 1 from the exponent. So what's left here is 1 plus, well, actually it'll be a minus because I'm going to multiply 2 times negative 1. So minus 2, and then x to the negative 2 can go down on the bottom as an x squared. There it is. All right. Good, good, good. Making a little bit of progress here. All right, let's now look at, we had a problem earlier where the arrow was shot into the air, and they gave us 58t minus 0.83t squared, and we went through and we tried to find its derivative, slope of its tangent line, and we went and did a lot of work for that. But let's just see how quick and easy this is now. We want this derivative. We have two terms because they're separated by addition or subtraction. So I just need to take derivative of each one of these individually. Well, the 58 sitting in front is a constant in front of t. Now t here by itself, if I take derivative of t, that's like me saying what's the derivative of x? Derivative of x is 1. Okay, or derivative of t in this case is 1, because t is our variable, so just understand that. You know, we're interchanging the x that we normally had with the t now. So over here we have another constant, 0.83, attached to a function. The function is t squared. Derivative of t squared is 2t. And now what we can do is just write 58, and then multiplying negative 0.83 times 2, we get negative 1.66 t. And that's what we worked like, 20 minutes for a while back. So very, very nice result here. The last two that I want to show you, I'll make quick, is the derivative of sine, the sine function, and the derivative of cosine. So derivative of sine of x is cosine x. And then next to it, the derivative of cosine x is sine x. These two need to go into your memory bank. These are very important. They come up a lot. And again, I believe I'm going to spare you the proof of these. You just kind of take them on faith for now, but please just go YouTube it. Just go look up, proof of derivative of sine or something like that, or derivative of cosine. It's a really nice proof. Again, if you want to see it, just contact me. Come, meet me in my office. I'll be happy to see it. I'm just really trying to cut down on some of the time on this video, so I'm not going to show you the proof of that. All right, that's going to wrap up those sections, and I guess you move on to the next videos. Sorry again that I had to redo this one. I don't like doing these at home like this, but it is what it is. You have at least something to go off of.